Hello, everybody, and welcome to the first Device Management Interface Brigade call of 2021. Thanks for joining. And I think I've already talked to everybody here, but Happy New Year if I didn't. Please be mindful of the fact that the call is public and recorded, and as usual, will be shared on YouTube. So please take note of what you're sharing, that it has no proprietary information. So first of all, I want to start where we ended up last year, which was a discussion on the proposal from Radisys for their device manager. There was a lot of discussion last year. I know that the team has worked a lot on the presentation and on the thoughts and on the discussion, and they're going to present two options for this. What I would like to ask everybody is to let the presentation end before we start the discussion. Because otherwise we are going to get stuck maybe in places and we don't have a full picture before we discuss this. So please be patient a little bit. I know the presentation isn't long, it's like a couple of slides. So just let it finish and then we can go ahead with the discussion and we can go back and forth on the slides. So Sean, Chandra, are you going to take it on?
Yeah, I think Chandra has the latest slides.
Sounds good. Yep. Chandra, do you mind unmuting yourself and presenting?
You're on mute, Chandra, if you're talking.
Hello everyone, this is Chandra here from Radisys. Hope my voice is audible.
Yes.
Yep.
Okay, thank you. I would like to just share my screen.
Yeah, go ahead, please.
I'm just trying to share my screen, just looking for an option. Sorry, Andrea, I'm not able to find option to share my screen. Is it because you're already presenting?
There should be like a bar at the bottom of the screen.
At the bottom,
gives you an option. Yeah.
It's a green button.
Yes.
Perfect.
Hope now you're able to see the screen.
Yes, we can.
Yep.
Okay, thank you very much. As we discussed in the last meeting, from Radisys, we would like to propose our contribution towards the Open Device Manager. Basically, that consumes the device management interface towards the NEM components. And the Open Device Manager also translates the API from the device management interface towards the device. We call that adaptation component as Open Adapter. And on the physical OLT box, we have the open device management agent that will be hosting the server and that listens to all the API from the open device manager. I'm sorry. So based on the discussion points from the last meeting, there were two options that were discussed. One is the physical OLT box directly implementing the device management interface, directly exposing the control towards the operator NEM components, OSS, BSS, or EMS, so that the external components can manage the states directly towards the device. And also that requires the OpenDM agent component to be able to directly publish the metrics and events on the Kafka topic, on the Kafka infrastructure hosted in the central location. So this is what we call as option one, what you see in this red line. the physical OLT open DM agent implementing the device management interface on the gRPC, receiving the requests and processing them and sending out the responses, and all the asynchronous event messaging happening on towards the Kafka, as you see in this line. This is one option what we see. And the second option is basically open device manager component that is sitting outside the physical OLT box, which implements the device management interface, talking towards the operator name components on the gRPC interface, and having a open DM adapter talking to device running the open DM agent. And it is also extensible. You can run different adapters for different protocols like netconf, redfish, etc. based on the device native interface on the southbound. We tried to just come up with the pros and cons for the options. Coming to the option 1, wherein the physical OLT box implementing the DMI interface directly, giving the control to the external components from the operator infrastructure to manage the device directly. So the main pros we see is that it is simplified architecture, and only we need to implement the DM agent that implements the DMI interface. And in the con side, we see that as this OpenDM agent needs to publish all the metrics and events on the Kafka bus, there is a need for Kafka infrastructure to be exposed on a external node port, on a external endpoint, so that all the devices can publish the events to the Kafka. And the next thing we see is that during the software upgrade of the device, whenever we do the activate of a software, the device might go for a reboot. In that case, the device connectivity will be lost. So the operator name components needs to manage the device connectivity appropriately. During the activate of a software or commit of the software, if there is any device reboot happening, those needs to be managed. And one more thing, as we are completely skipping this open device manager component in option 1, so the complexity of the open DM agent will be little more, as it has to maintain the persistency of the states on the device itself, so that it supports all the different features such as the hardware management, software management, and metrics and events, basically all the threshold configurations, and raising the above, below, and crossed events based on the thresholds. So that will be increased complexity on the OpenDM agent running on the device. And coming to some of the points that are captured in the device management interface, there are some designated responsibilities for the device manager. Basically, allocation of the UUID, which is unique ID for each device. So this can be managed irrespective whether Open Device Manager assigns the UUID or device itself. We can arrive at a unique identity based on the serial number and MAC address, both considered. And coming to the software upgrade, the intermediate states and all needs to be managed. This needs to be either managed at the NEM or either at the OLT. And the OLT can always talk on the simple DMI interface procedures that are already defined, and the complexity residing in the OpenDM agent software. So this is about the option 1. And coming to the second option, wherein we have a new component altogether called Open Device Manager, which implements the DMI interface and talks to the devices on different southbound protocols. One advantage we see that this architecture or design can be extensible for legacy protocols towards the southbound devices. And device manager can take care of the device connectivity and the intermediate states during the software upgrade. And in this case, as Open Device Manager also runs in the same Kubernetes cluster as Kafka, we don't need to have the Kafka bus exposing the external endpoint, as it is all internal and it can be secured with the Kubernetes internal cluster. And with the device manager taking in much of the complexity, the code that runs on the box can be less. And this will be an advantage because any software updates that are required just requires the software upgrade on the Open Device Manager, and no need to update the software on each and every boxes. So that is one advantage we see. And coming to the cons, we need to extend the same DMI interface, as we are proposing that this interface is also based on the gRPC. We need to have the gRPC itself to be able to receive all the events and metrics. We may have to use the gRPC streams to have the metrics and events communicated from device to the device manager. And also we see as this interface implementation and this interface implementation mostly similar, then there is a code duplication happening. Same code needs to be implemented here as well as here. That is about the code duplication. So these were some of the pros and cons we discussed, and we would like to now hear from the community what you think about both of these options, and would suggest us the way forward. Thanks a lot for listening. Now we can discuss. You can please share your inputs.
Thanks a lot, Chandra. I'll let folks speak up and tell us what they think.
Do you really mean it? Should we put aside the arguments that I continue to think that building a EMS out is part of Volta under the ONF umbrella is probably the wrong thing. So putting aside that argument, this goes back to the standard. Is ONF pushing a standard that they expect to be implemented by all devices, or a standard they want implemented in a software intermediate layer? Originally, ONF came out and pushed for OpenFlow, which was a device they expected to be implemented in all devices. That being the case, the second option kind of goes against that model. It says no, devices are going to remain as they always have been up to this date for the most part, have an independent and vendor-specific API, and we're going to create that abstraction off-box, which is the way EMS systems have been built for the past 40 years, probably by now. Or is ONF going to push we're trying to normalize the interface on the device, which is more towards option one, and therefore ONF will push that direction and only support option one easily. I mean, there's always ways around it. So I think that's kind of the fundamental question in my mind.
So there's a couple of things to that, David. One of them being that at the moment, the current DMI, to me, especially from the Kafka perspective, it's kind of difficult to run on the box. Because at the moment, the Kafka bus we have is really kept internal only to the cluster. So exposing it would require the security, which is something that would go in for every message that goes in the Kafka bus, including the ones between the adapters, the core, and etc. Just because we want the metrics to be communicated from the device to the Kafka bus. I'm not saying it's impossible. I'm saying it's one thing that needs to be taken into consideration. The other option is that we extend the interface to use gRPC streams for events, which is again doable, no problem. That's another option. The third thing is that with option one, there's a lot of logic getting baked into the OSS, BSS, NEM of an operator. I am not sure if the operators do want that. I'm actually mostly confident, and the initial idea of the DMI was precisely to avoid any complexity in NEM.
So you're referring there to the logic that was referenced earlier, when a device software upgrade happens, and from the northbound client, it is seen as a hardware reboot, right? So that would be the same as if, for the second option, if the Open Device Manager upgrades, crashes, upgrades, whatever, the NEM's going to see that as well. So the NEM's going to have to deal with component restarts. It has to today, or should be doing it today. So I'm not sure there's a difference, a real difference, in the NEM seeing the Open Device Manager restart versus the DMI restart. If we're talking about software upgrades, I'm not sure that we're going to see those that frequently, because I suspect operators don't really upgrade software unless there's really need to, because it represents disruption.
Agreed. Agreed. The downside to that, the flip side to that is that if you have to update the implementation of the interface itself, in the case of option one, you would have to go and update, like, I don't know, 100, 1,000 devices. While if you have to implement a change of the interface in option two, you would have to change just the manager. Granted that the manager is then capable of handling the update of its own agent on the box.
When you talk about upgrading the interface, you're talking about upgrading the device manager interface, correct?
Yes, the API, the protobuf that we define.
Right, and the counter argument to that would often be, and if you have to update in the option two, the Open DM agent,
Yes,
you would have to upgrade to 1,000 devices, right? So I don't see these kind of con arguments against option one, I think, have a parallel in option two, right? It's just where the upgrade happens, right? So you say in option one, if you have to update the DMI, well, then you have to update 1,000 places. Where in option two, you update it one. But the counter argument is the Open DM agent, right? If that interface changes, which is also a gRPC interface, then you have to update 1,000 in both, right? So there's these counter arguments, so or parallel arguments, right, or parallel issues in both of them. And this is why I say it really comes down to, what does ONF stand for? And does the ONF stand for, hey, we're going to try to normalize the interface on the devices cross-vendor for management? Or are we going to essentially say, look, we're going to let devices speak whatever they want, and we're going to do the abstraction off box? To date, I won't even say to date, but with ONF's inception around ONOS, the concept was, we're going to normalize the device in the box. This is the new way to do network management. And people are going to comply with that. Now I understand ONOS had some ways to get around that with drivers, specifics, to support other protocols as well. But let's face it, ONOS really supported OpenFlow. And so the question here in my mind is, which way is ONF going to go on that? More kind of how they treated ONOS and OpenFlow, and now P4, or are they going to treat it more as a traditional, what we've seen in the last 40 years for EMSs, which basically acknowledges that we're never going to get vendors together, And so we might as well write the abstraction off box.
And what about the issues related to the Kafka bus?
The Kafka bus, so there's two issues that were raised. One was exposing the Kafka bus, and to be honest, we need to be able to deal with ingress controllers anyway on multiple services. So I think that's a problem that Kubernetes solves. So I don't think we have to. We just haven't deployed any ingress controllers today. So I think the exposing the port is kind of a non-issue. If you're talking about security in terms of authentication, yes, clients in some sense. We basically said a cluster is a secure environment, and therefore anything in the cluster can talk to Kafka without repercussion. That's not necessarily true. I think that is a false level of security, which is why I think even today, regardless of this effort, we're going to have to provide certificate authentication for our clients so that we know who's talking to what, and we're protecting that. And whether we do that with a mesh like Istio or something else, irrespective, there's multiple ways to implement it, but I think we need to do that anyway. So I think that, again, comes to, in my mind, I look at that as almost a false argument. This isn't, well, this would use that. This isn't the only reason we need to do that security. And you could, as I think you pointed out, or someone pointed out, might it be that rather than Kafka, the DMI interface really is gRPC streaming interface as opposed to Kafka interface, and we could go that route as well.
Well, so that brings in the question okay, we might say, well, the request was for Kafka.
Yeah.
Okay. And so at the moment, we need to put that Kafka piece on the box if we want to satisfy the request. That there's really no way around it. We could look at possibly extending it, but still the Kafka piece would still be there somewhere. Not there, but somewhere.
If we continue to go to Kafka, and this, if we continue to decide we need Kafka, yes, you're absolutely right. And what Kafka provides is persistence behind a message stream. And the theory there is, therefore, if either a generator of events or a consumer of events, producer or consumer of events, goes away, the messages are persisted. So when they restart, they can replay some of that. That's what Kafka gives us. If you go to a gRPC only streaming, then if a consumer goes down, it is possible they would lose messages unless there's some retry mechanisms or buffers or whatever, right? So it becomes an issue of implementing that ourselves, which I don't think we want to do, which is why there's Kafka there. And so then you come back to what's the use case, right? Is the use case that the consumer of the events from the DMI must not ever, ever, ever miss one? Or is it okay for them to miss them, right? And that's when you go back to kind of the architecture design and try to understand the event streams and the consequences of events being missed, and how do you reconcile. And it might be that best effort messaging between the DMI and the northbound client is sufficient. It might not be. I don't know the answer to that. For example, if the events are being used to track the state, it's always, and you can always, instead of say I never want to miss events, you can always do the query state and subscribe model, which basically says I want to resync the state that the device has and get all future events. And therefore, for a northbound client, you still have an accurate representation of the device state. So there's ways around that if we didn't want to use a Kafka bus, and that's a big decision and not something we're going to decide in this meeting, I think. But it can be done. It is done today. But again, if we want to continue to use Kafka, I think we already have to deal with ingress servers on other services. We just haven't yet. I mean, even Volt Cuddle needs an ingress controller. We're faking it with port 40. The security issue is, as I said, I think we already need to do certificate authentication between our components. So I think we've been pushing that off under a false pretense of security when it's really not.
Okay. And then really, these are more technical details, and that we can solve them, and I agree with you. But and I'm playing devil's advocate here. I want to discuss every point. The major one that I see is state. What was mentioned here in terms of like image update, image download, or like internal device states, because I know that the DMI offers like a set of states that the image download and software update process can go through, but there might be more needs within the system, the device, or more intermediate states. It doesn't necessarily have to be uploaded somewhere or needs to be showcased somewhere, but the device needs to go through. And if you say that the device itself just updates the image and the DMI is on the device, what you risk is that in case of failures, you cannot really recover. Because it requires state within the device that the device loses because it's trying to update. And then you would have to have a lot of logic in them to counteract all this mess.
Nope, and you're right to play devil's advocate, so that's absolutely the right thing to do. So during the discussion, there was a couple, state was called out a couple ways. One was like, I think they mentioned thresholds, right, for capability. And so again, the device is an OS, it has a file system, it has mechanisms to store information. So things like thresholding or values or those types of state values, I think, pretty straightforward to be able to store on the device. I wouldn't go so far as like say, hey, let's just install a database on the device. I think that's probably too heavyweight for what we need. In terms of the update argument, where you're trying to update the DMI on the device itself, and you push a new image down, and it somehow fails, whether it fails in download, whether it fails after restart. How does the device recover? So devices today deal with image updates and recovery all the time, right? You download the new image, you do some sort of verification of that. You try to do a best effort verification on it to say that it's good before you actually try to do it. And then rather than just replace your current executable, you say, hey, let's try to restart this one and start the new one. And if the new one starts, great, everything's good, you make that the default. If you try to restart the new one and it fails, you fall back to the old one. So again, devices do that today with images. So I think there's a precedent already on how to manage that.
Okay. I would like to hear also somebody else's opinion on this, just not myself and David. I would like to hear thoughts and points from other folks.
I mean, I'm actually a big fan of solution 2, which I cannot see anymore. So, I mean, for us, it was pretty simple to just create a new device manager without nearly any change to our OLTs. So there were some slight changes for certain alarms which were required by customer, but overall it was pretty simple for us. So we could keep the device as it is, and we could use the device manager to orchestrate things like, especially the software update, which is a multi-step process, which includes a reboot and everything. So it was pretty simple for us. And So I'm very much in favor of this, the second solution. And I also do not see the one con which is mentioned, this DM adapter interface. So that you have to extend the DMI. I mean, we didn't do this. We just used our native interface. So it was, yeah.
Well, yeah, the point here is the fact that for Radisys, they currently don't have an interface there. So that's a good point, Holger, that I completely agree with that. For legacy equipment that already has an interface, that already has an OS, that's already living maybe in the field, option 2 is the way to go. And there's no doubt about it, period. And this is also something related to what you guys did, and it's perfect for you because you already have it in the field, you already had the OS there, you couldn't start fresh, and it works. But what, to David's point, whatever gets upstream into ONF, and it kind of needs to deal with possible different scenarios. And with Radisys, they are starting from a plain field. There is a white box OLT. They don't have such an agent on there that exposes these things at the moment. So the idea here was, let's build the best solution possible. Having
I'm sorry, I didn't mean to interrupt. Go ahead.
No, that was it.
Okay. No, I agree with Holger 100%. Actually, the second solution is easiest, right? It's just what has been done for 40 years. So it's no different than what has been done for 40 years. And so if we were really looking at the second solution, to be honest, I'd be going off and looking at existing open source projects that focus on device management and see if they fit. And if they almost fit, I'd be looking to contribute to those open source projects, right? It's just, it feels, option 2 to me feels like this is another open source community trying to develop yet another open source EMS. And while I have no objection to an open source community doing that, I kind of have an objection to thinking that's ONF's role. Because ONF has always been so focused on looking at the next generation, what is coming, not necessarily dealing with what exists. And I know that's hampered them in some level because there were some issues around when OpenFlow came out. Not all devices support OpenFlow, and they were pushed back that, hey, we have to deal with legacy devices. But they kind of stuck to their guns and said, okay, you know, we're gonna push OpenFlow, and now we're gonna push P4. And so we're focused on that next generation, what network management should be, not necessarily what it is. And this solution, option 2, feels very much like, you know, yet another EMS. So it's more of a philosophical question. I mean, technically, I agree with you 100%. It's easier.
But I mean, it's not a full-fledged EMS, right? I mean, it's just some simple options which are actually missing in Wartha.
It is not today a full-fledged EMS, but I also see it as a slippery slope because it will, my fear is it will expand over time. And so this is why I say if it would be easier in my mind to say, hey, let's go see if there's an existing open source EMS that fits this bill.
Yeah, I fully understand that it's a slippery slope because I also see at our customer that it's always if you need something, then what about doing it by the device manager?
Yeah.
Why not add it there? And yeah. But I mean, do we really have to decide about that? Wouldn't it be possible to have a DMI interface which is used by option 1 or option 2, so the same interface, and you can decide, so an M can decide, not decide, but I mean, it's depending on the device. So if you have a device which talks DMI, an M will directly talk DMI to the device. If not, you have an option 2 in place for that device, and it's basically the same interface. Why is it?
Well, there's some also issues around, is the DMI interface what I'll call a one-to-one interface or a one-to-N interface, right? So if DMI,
Yeah, I mean, this has to be solved. I mean, currently we have some, we address a device using the interface, and if you already talk to the device, then you don't have to address it anymore, for sure. But
I don't think the one-to-one or one-to-many is something that we need to bake into the interface. At the moment, we have proven that it works one-to-many and one-to-one. The one-to-many is the ADCAL implementation that Holger showed a while back that works with, and the one-to-one is BBSIM. On BBSIM, you have a one-to-one relationship OLT to DMI. So I agree that with Holger that the interface can be used in both ways.
yes,
The caveats that we talked about is just what do we suggest? What do we say to Radisys that is asking us what is the best option for them to implement it? This really is the question. What do we tell them to do? Because they came to us saying, we want to contribute this, we want to build this. And how do we do it? What's the best option? What does the community think? What do the operators think? And this is really what we are debating. The options are both valid, and there are no technical reasons why either of them can be done. It's just, what do we tell somebody that starts fresh?
yeah, that's fair. I think my opinion is the minute you enable option 2, most vendors, and I come from a vendor, will go option 2, and that's because it means less change on their box, right? And I'll be honest, vendors look up. I can't speak for all vendors. When I've been a vendor in various different companies, and I've looked at standards interfaces, and it's often said it's easier to adapt to the standards interface off box because, one, as I said, no changes to my box. 2, whether we like it or not, standards change. And so if I do it off box, if standard X is in favor this week, great, I can do it standard X. When standard Y is in favor next week, I can do standard Y, and it doesn't affect my box. The downside of that is often that standard X nor standard Y often expose all the capabilities my vendor API exposes. And so for managing the box, it often becomes standard X, standard Y, either with extensions or additional going directly to my box. And that's why vendors do option 2, right? Because that DMI changes too frequently depending on which project you're working with or which customer even. So I get the pull to option 2, and if we go option 2, I'm okay with that. But I do think we have to acknowledge that we're just building another EMS. It's a slippery slope, and it seems a little out of line with ONF's original goals.
So there is something that I still have to figure out in this whole thing is that, let's say we go for option 2. What I wouldn't like is to build a very similar interface on top of the DM agent. Because at the moment, and Sean, Chandra, correct me if I'm wrong, but you don't have such an API. So the idea would have to have a gRPC API that talks to the device and to the DM adapter, correct?
Yeah, that's right. We need to add that interface.
But Sean, for option 2, couldn't we just remove the open DM adapter altogether and say, look, option 2, we have an open device manager which has plugins, and those plugins can talk whatever protocol they want to whatever device they want. There's no necessarily value for an open DM agent and adapter.
So this is kind of what I was talking about, an option 1.5, let's say. So, so it's like, yes, I mean, you can use the same API for device management agent as well as the open DM agent, right? Because it's essentially just passing through, right, in that case.
Yeah.
But you still, if you still need that open device manager / adapter piece. Let's say you want to go to gRPC streams implementation for PM and events, right? So they would go over a separate gRPC streams interface, and then the open device manager would then kind of adapt to the Kafka bus, right? As a halfway kind of approach. And that's kind of another option.
But what I'm suggesting is, if we have a DMI definition and we have an implementation of that interface on the open device manager, and that open device manager has an internal iAdapter interface, going back to the old Python stuff. Does it really matter what the protocol is between the open device manager and the physical OLT? It could be SNMP for all we care, right? Right now,
it could be, as long as the data model matches, right? I mean,
Well, it would be presumably the open device manager would have multiple adapters, one perhaps for each vendor, one perhaps for each vendor model.
Sure, yeah. You could have redfish or whatever between them, right? Yeah.
Right, and so if we even go back to Onos, right? Onos has these core constructs, flows, and interfaces around those that anybody can implement to any protocol. And so, kind of the translation from vendor specifics to abstraction happens in the adapter. And if that's the case, I don't necessarily see the need to have an open DM agent. You just have a bunch of adapters in the manager.
Well, the thing is, David, you need something on the box that talks a language to the manager.
Boxes already have an interface.
Which ones?
Who cares, right? The adapters in the device manager. I don't care if that's Redfish. I don't care if that's SNMP. I don't care if that's a proprietary gRPC interface.
No, that is the point. The Atron box, they have the liberty, sorry, the Radisys box, they have the liberty to choose that interface.
The Adtran box,
so right now the interface between for the Atron box is netconf Yang. For Edge4, they're proposing Redfish, right? So we're saying, well, can we just use gRPC as that interface? And we have an open DM agent that talks gRPC and then adapts that to the ONLP access for the KPIs and the PM. Right?
Yeah, but again, if a vendor chooses to do that, that's their choice. I think then it would be if a vendor chooses to go use the netconf there as opposed to a gRPC interface, that's their choice. It's up to the vendor to decide if they want to write both sides of that conversation or not.
That's right. Yeah, sure. And what Radisys is proposing is, can we provide an open implementation of that based on gRPC?
Where an open really means we've decided a protocol between these two ends, a gRPC interface, and it's a shell that rests on the physical OLT that any vendor can use and adapt.
Yes.
Again, I agree 100% with the technical issues that yes, this is easier. I just think it's also what's happened for 40 years. And that's just a little disheartening, but I also understand why it's happened for 40 years.
So what about the option 1.5, which is we extend the DMI with gRPC streams. We implement only gRPC on the box, and then have a very simple shell in the in the device manager that does a pass-through for everything that is not streaming, and for the streams, it redirects to Kafka.
Yeah,
So
we also need to, also take into account this, one-to-one or one-to-n models as well, right? So
yeah,
maybe
the minute you inject gRPC streams or an intermediate to Kafka, because right now we're saying Kafka has a history of messages and is kind of our HA capability. So the minute you interject something that doesn't have that capability, such as gRPC streams, you introduce the problem of messages being missed. So if we have a small intermediate that reads streams and publishes to Kafka, that intermediate could crash and therefore we lose messages, right? So you introduce that immediately. And so therefore you have to answer the question of how do we deal with missed messages? And if you're going to answer that question, you can really start just putting gRPC streams everywhere because you've answered the question.
Yeah, the problem is that it was an operator's request to have the Kafka bus in there. It was not my choice.
I'm not arguing Kafka or not Kafka, really. I'm just saying the minute you introduce streams where the source of an event does not talk directly to Kafka, you introduce the possibility of missed messages and therefore have to answer that question. So that's all I'm suggesting. And then I guess the follow on to that is if you're going to deal with missed messages, then eventually a simpler architectural approach might be to say, look, we have to deal with missed messages anyway. We can get rid of Kafka now, which reduces the complexity of the system, reduces storage requirements of the system, because we've answered the question about missed messages. And that might be a logical extension down the road. But you cannot, in my opinion, introduce an intermediate gRPC stream consumer that publishes to Kafka without answering the question about missed messages.
By the way, we also have the problem of missed messages for our Adreno OLT because we're using netconf notifications, and if you have a reboot or something, so you could miss notifications. And so this is something we will implement in the device manager, which is not on the box. So we will try to, especially for alarms. So if you miss a clear alarm, for example, or you miss the raising of an alarm, while the device was not available because it booted or whatever, so the device manager will take care of that.
Okay.
So this is some additional functionality which you might not get on a device, because which is a benefit, I think, of option 2. So you can, because you know that as a Kafka bus, and there probably is not the possibility to losing messages there is nearly zero. So the device manager will take care of that and will just regenerate messages which were lost.
So
to do it not on the device.
Yeah, but you would also need
so you're buffering messages in the device manager layer and then replaying them. Is that my understanding? Is that understanding correct?
We actually, no, we are persisting alarm states, for example, and then we check on the device. For example, if we lost the connection to a device, we will check on the device if these alarm states are still there, or if there are other new alarm states. In this case, we would recreate messages which were lost.
Yeah, it's essentially an audit, I guess, right?
Yeah, exactly. Yeah, every time we lose a connection to the OLT, we will do an audit after the connection is set up again. And which is, I think, easier to do out of the box than in the box, because you never know in the box if there's something, some intermediate which could lose messages.
Yeah, I was right. Again, then that at some level is pushing the problem upstream, right? So if the device manager is doing that audit and reconciliation and then regenerating events to the upstream, in this case, Kafka,
Mhm.
that's fine. But I mean, as long as Kafka gets all the messages, and we're pretty sure Kafka will publish all the messages. But I guess the question is, that same reconciliation could happen it typically happens on the consumer up above it, right? You
Yeah.
always say, go get my state and the event flow. So I have the current state and I get all events going forward. When I lose connectivity, I do the same thing. Get my current state and all the event flow, right? So doing that at the device manager level and then generating events. Yeah, and I understand why you did it that way, and I probably would have made the same decision. I'm not thrilled with it because I guess I would have said, hey, do that to NEM, right? Just why add an intermediate layer here when the NEM could do that, presumably.
Yeah, but the problem here is only that the NEM is done by some, like the different people, not us. So they expect us to make it right, and they write bug reports against us. So we have this already, and not for the device manager, but for other systems. And so we try to be here as clear or as clean as possible. And I mean, there can always be scenarios where you will lose messages, but so it's.
No, I agree. It's just I like the model where the consumer of the event does that as opposed to an intermediate, because anytime an intermediate does it, as you said, you have the possibility of losing that event somewhere else, and the eventual consumer still has the same problem.
Yeah.
Okay.
And one of the problems here is that it's really heavily device dependent. So not every device might have the same problem, and the ways for solving the problem are not the same. So it might be difficult for NEM to do it for all devices.
I get that.
So guys, the thing is, I want to come out with the decision, with a decision, a suggestion to Radis of what to do. So I would like to reach some consensus, or at least to suggest them what's the next step to take for this. If I had to say, what I would do is that the first component that still needs to be developed is that DM agent, okay? That DM agent has to be developed independently of either we put DMI on it or we put some other gRPC on it. So what I would do—
I thought that's what we said. The open DM agent doesn't have to be developed, because if a vendor wanted to speak netconf or SNMP or carrier pigeon between the open device manager and its physical OT, it could absolutely do that.
David, they have to do it. They have an OLT which doesn't have anything like that. So they have to build this.
No, they choose to build it.
No, they have nothing. They have nothing.
So, Radis, you have no management interface on your box.
It's not like Acton that had a server on there. They have nothing.
No, we're providing a white box, right? So we want to make sure that the open source community has all the components needed to make that white box work with any kind of operators, implementation of Volta or So we want to provide a white box that has all the components needed, right? So that component is needed, that it's not available in open source right now, right?
You currently don't have a management interface to your box.
The white box OLT running the open OLT agent doesn't have a management interface. When you say
so
that.
There's no netconf, no SNMP, no nothing. Okay.
That's right.
So you need to write some management interface. If you want to call that open, what is it? DM interface.
Open DM agent.
Agent. I mean, I don't care. That's the implementation. I mean, what if you want to expose the DMI on as your management interface? That's your choice.
Mm-hmm.
If you want to expose some other And as long as you're the only ones that actually use this, even if it's open source, it's proprietary, right? So,
Well, no, I mean, the code's available for everybody else to use if they want to use it. Right? So we're just providing an example, like the OpenOLT agent, right? I mean,
right.
You know, Adtran doesn't use the OpenOLT agent, right?
Right.
But others do. Right?
Yeah. So it's again, it's your box. You can do what you want.
It's
Have
a white
fun.
box. It's it's everybody's box.
Have fun. Knock yourselves out. I mean, yes, you need a management interface.
But do you need streams for events? Is it something you want to have, or would Kafka be okay for white box?
Yeah, I mean, Kafka would be okay, but there are these, you know, the cons and the pros that are listed, right?
Mm.
So, you know, it's you know, more effort, I guess, to get to a Kafka interface. You know, there's the security issues that you need to address.
Yeah.
And apparently, I think David was saying that those securities really need to be addressed within the Kafka, I mean, within the Kubernetes cluster anyway.
Part of it is Kafka is an outgoing interface from the device manager, right? The device, the box would have to contact something else. gRPC and gRPC streams is the box. Anything on the box is essentially the recipient. It doesn't initiate the call, and so there's different requirements about it, right? It just sits there and says, "Hey, if someone wants my events, call me and I'll send them to you." There's still security issues around that because you really want to authenticate and only give messages to someone who actually has the right to do it. But with Kafka, all of a sudden you have to provision on that box not only certificate to authenticate into Kafka, but also the endpoint that Kafka resides on. Right. So it's an active, not a passive.
Okay. So let me see if I can get this right. I think the best step forward here is to start with that agent and implement the DMI on it. And as soon as you get to the events, make a proposal for having streams for these events, meaning extend the interface to include the streams.
I think this would only be one RPC. I mean, all the events are already defined as protobufs, so you only have to define one RPC, give me events.
Precisely.
I think that's all. Yeah.
Precisely.
So that should be easy. That's why I ask about this. This should be an easy solution for just getting rid of Kafka for this specific use case.
Yes. If I was Radisys, I'd be doing gRPC streams because being passive is a lot easier.
And as soon as you do that, make the proposal on the upstream device management interface. And what that gives us, it gives us the option to choose streams or Kafka. And then if we decide to go ahead and have a next step that is to build the device manager, well, then that device manager can expose Kafka.
Well, yes, it can. And I agree with what you said. I'd at this point start around Volta as well as around the device management stuff saying, hey, can we start using streams more, eliminate Kafka, and just answer the question about how do we deal with event misses and sync state. But that's me.
And I will start here because this in any way needs to be done. Meaning that if we, in any case, you will have to have something on the device that talks gRPC that includes the streams. So might as well make it DMI plus an extension to gRPC streams. And then if the operators say, no, gRPC streams we don't like, we want to talk Kafka, we need Kafka, Kafka is fundamental, we build that adaptation layer in the middle. That talks to Kafka. And if we see that the state becomes a little bit too much to keep in the DM agent and in the NEM, we extend that middle piece or we build that middle piece. But what I would do is, if you guys are okay with that, I mean, it's your code, it's your stuff. I'm anybody to say this, but nobody. But I would start there. Start with this, implement the DMI gRPC protos, and extend them with the streams. That's it. And have it running on the box. And as soon as you have it running on the box, we take the next step, which is the device manager if we need Kafka.
Yeah, I think that's a good good first step.
And have it done in 2 weeks.
And as always, I am very open to open sourcing that piece. So as soon as you want, we can discuss on what's the best options, what the best option is to open source that implementation of the DMI agent that sits on the box. But
Yeah, I mean, yeah. So we'll probably start there, and you know, there may be things that come up along the way that maybe put nudges one way or the other in terms of what we do with the device manager.
absolutely. And it can nudge us also in how much we put in one or the other, in terms of if we build one, if we build both, how much stuff does it fit in both? And again, when I say we, it means the community to ease. ONF is not really doing it, and this is Ramsey's proposal, and they're putting in the work. So we're just suggesting it.
So when I say we, I mean you, but okay.
Yeah, exactly. that was understood.
That means we
And please have a look, especially at the software update, if this really is possible doing on the box, because it's really, I think, a little bit complicated, because normally you would send an event, so you would send an RPC, activate software or whatever it is called, and then after the activation is done, so after it was rebooted and everything's working fine, you would respond on that stream, and this is not possible. So I don't know how it would be different.
Yeah.
So you would have to send a response already before you're rebooting, because there's no way to keep the stream up if you reboot something. So this would be a little bit different than how it is currently handled.
Yeah, but you know, the Open Device Manager may have some functionalities as well. But we'll see how that goes. But we'll obviously look at the software upgrade.
Yeah, but I guess there's no way to keep the stream up.
Yeah, the manager would have to reconnect.
It's going to go down and not come back up.
The manager would have to reconnect, which means if the when the manager loses connection to any device, it's going to have to sit there and say, "Hey, I've lost connection," and report that some way, and then say, I have a retry policy, and maybe I retry immediately. If that fails, I back off, and eventually I'll reconnect.
Yeah, this is totally fine, but currently the RPC is defined in a way that you say activate software, and then you will get a certain kind of responses back, several responses in the stream, and then when the RPC is finally done, then you know that the software update was done, and this is normally after the reboot.
So you're saying the interface, yeah, but that tells me the interface is wrong, but okay.
Yeah, maybe, yeah. Maybe I don't know. I mean, it's different from other software update interfaces where you have to do a commit afterwards. So where you actually do a multi-step approach from the outside. So you do a activate, reboot, commit, or whatever. So you do 3 steps, but currently it's only 1 step, which does everything. So the device manager does everything because he's not running on the device. So this will be a little bit difficult, but yeah.
Yeah, I mean, there's a reason everyone else does it with 3 steps, right? Because it works with the disconnect.
Any outcome of this effort that might make the interface better, we are always open to accepting changes to it.
So, Andrea, I have one question. Maybe I didn't get that clearly. So, what you were saying was that maybe the DMI interface is extended to support getting the events on the gRPC stream. So, if that is done, then what is the expectation on the NEM? So, the NEM should support both the modes, Kafka as well as the streams for different kinds of devices. Or are we saying that we take out Kafka and only have support for streams?
Well, just my understanding of where we ended up was basically it was like a 1.5 implementation where, you know, the DMI interface for configuration goes right from operator name essentially through the device manager transparently to the open DM agent. And then for events and PM, we can have a streams interface. I mean, and this is like a second step, a streams interface going to a device manager that adapts to Kafka.
Yes, and
Is that everyone else's understanding, or
Yeah. Because I mean, on the device, the agent on the box is much easier just to have a gRPC server rather than also have a client that needs configuration.
And if the operator wants Kafka, there's this little middle piece that has Kafka. Takes the gRPC stream and converts it to Kafka. But to David's point, maybe we don't need Kafka in the future. If an operator decides to go all gRPC, it can go all gRPC directly to the box.
Yeah, thanks. Good answer.
Okay, given that we are over time, I think that thanks a lot for the discussion. It was great. It was very good. And
yeah, thanks, everyone.
Sean, Chandra, you have the next steps, right?
Yep.
And please do let us know. Keep us updated on how things go, and let's take it offline on how it's best to upstream this code. If you want, we can discuss differently. And let's reassess in 2 weeks. Sorry, Amit, if I we did not have the time to make the presentation about the reasons. I think just a quick comment. There's a patch on Gerrit from Amit that talks about that has a proposal for the reasons, as we have discussed in the past. Go please take a look at it. I'll post it in the chat in Slack in the channel. So just go take a look and make a review of the patch, please. And that's something that we want to get done as soon as possible and discuss as a proposal. So worst case, we're going to discuss it in the next call. Okay. Thanks, everybody. I'll publish the recording as soon as I can, as soon as I have it. Cheers. Bye-bye. Have a good
Thank you. Have a nice day.